Hi, everyone. Today we're going to start chapter 10. So we're going to start talking about hypothesis testing. In section 10.1, we're just going to do a kind of an overview, an introduction of what hypothesis testing is, how we set them up, and things like that. We're going to talk about the language of hypothesis testing. So this section is a lot more conceptual. We're not going to get into the actual analysis. We're not going to actually use StatCrunch at all today, but you're going to get an idea of where we're going in the later parts of chapter 10. So, like I said, this is another key concept in statistics. So we started in chapter 9 with confidence intervals. And when we were dealing with confidence intervals, that was our first time using inferential statistics. Okay, now we're going to do something else. So instead of using those confidence intervals to say, hey, where do we think that parameter lies? Now we're going to test a claim or an assumption about where we think it is. So instead of saying, oh, where is it? It's probably between 80 and 85. Now we're going to say, hey, we think it's 82. And we're going to evaluate the evidence to see if we think that statement can stand or if we want to overturn it in favor of something else. Okay. We can actually, these are very much related to confidence intervals, as we'll see. We can actually use confidence intervals in certain settings of hypothesis testing. We'll talk about that more specifically when we actually do them in 10.2 and 10.3, but confidence intervals and hypothesis testing are very much related. So in a nutshell, hypothesis testing follows kind of the same procedure, okay? We're going to make a statement about the population. So we're going to talk about a parameter. In our class, we're going to talk about proportions and we're going to talk about means, okay? So we think that the proportion of females at Greenville Tech is 47%. Or we think that the average height for, I don't know, 17-year-old females is 63 inches, okay? That is going to be our initial statement that we're going to be working with. Then we're going to collect our data through sampling, surveying, things like that. That's going to be our evidence. And then we're going to use the statistical methods, a lot of what we've already learned, to analyze that data and then determine how likely it is to see the results that we saw. Okay. So basically all we're looking for in that evidence during that analysis is to see, do we have overwhelming evidence? Is there enough evidence to tell us, hey, I think that original assumption or that original statement is false, okay? So we're going to be looking at that original statement that we're going to call the null hypothesis, okay? So this initial statement, of course, the pen isn't working on here. The initial statement is going to be our null hypothesis, and we're going to talk more about that in a minute. But basically, that is going to be the basis of our test. We can only make two decisions. These are the only two that we can make. We can either reject the null hypothesis or we can fail to reject the null hypothesis, okay? So we're either going to say, nope, we have evidence to throw out that original assumption, or we're going to say, we don't have enough information to overturn it. So it might be true, it might not, okay? Nowhere in hypothesis testing do we prove. Do not use the word prove. Okay, we are not proving anything. We are looking to see if we have evidence in favor of it, okay, or evidence not in favor of it. That is all we are looking for when we're doing hypothesis testing. We still remember probability. Think about those distributions, right? We talk about the tails of the normal distribution going out forever and ever and ever. It is possible that by chance you land in one of those tails, even if your assumption was right. So we don't ever prove. We're just going to talk about probabilities here. So the first thing we have to do is define our hypotheses. So remember, we have to make our statement or make our claim, okay? We have two things that we must define. We have our null hypothesis, which is that original assumption. And then we have an alternative hypothesis, which you can kind of think about it as the opposite of the null, okay? They're going to make statements about the parameter in question, okay? We can talk about, for examples throughout these slides, you can talk about any parameter you want. But we will only perform tests for P, for our proportion, and for our mean in this class, okay? We can talk about writing hypotheses for anything. We can talk about the range, the median, the standard deviation, whatever you want. But when we get into actually performing these tests, we're only going to talk about the proportion and the mean, just like we did for confidence intervals, okay? The hypotheses must be mutually exclusive. And if you remember, that means they can't overlap, okay? So that's the important thing. You can't have an overlapping area. And something we're going to talk about as we go through today is the courthouse example. And you'll see this in a lot of statistical textbooks. It's more of a take the math out of it and just think about it in real world terms, okay? So think about when there's a jury trial, okay? The general assumption is innocent until proven guilty, right? Now I've used the word prove here, but bear with me. We're going to make the assumption that the defendant is not guilty, okay? He's innocent. And then it is the prosecution's, burden, I suppose, to present enough evidence to make the jury say, hey, there's overwhelming evidence that this guy is not innocent. We're going to overturn that and we're going to convict him as guilty, okay? So we're going to come back to that reference kind of throughout today as we go. Now, for some students, this is really helpful. Okay? It's a really helpful analogy. For other students, it's more confusing. So if you find yourself in the confusing boat, I wouldn't lose any sleep over it, okay? I'm not going to ask you to define it on a test or anything like that. But if you, for the students that it does help, it's quite helpful in making that conceptual realization. Okay, so the null hypothesis, like I said, is going to be kind of our big original thing that we're going to be dealing with, okay? We're going to denote it as H naught, okay? We say this as H naught. It's H sub 0, okay? It must contain equality. Now, in our textbook, that means our null hypothesis will always have the equal sign. Now, there are some texts, so if you're in Google land, okay, you can have that less than or equal to or greater than or equal to, but for our class, only deal with equals, okay? And the null hypothesis means that there was no change, there's no difference, status quo. Everything is the way it's supposed to be. There's nothing weird going on. There's nothing sketchy going on. It's just, our assumption is what it is. The null hypothesis is the subject of our test. So this is what we are going to decide whether we are going to reject if we have evidence to overturn it, or if we're going to fail to reject if we do not have evidence, okay? So it is what we are looking to overturn or not have evidence to overturn. So in our courthouse example, think about it for a second. What is the assumption that we're working with unless we have evidence to show otherwise? Our null hypothesis in the courthouse example is going to be that the defendant is not guilty. Okay, that's a U. Otherwise known as he's innocent, okay? So our null hypothesis, that kind of general assumption that we're making, is that the defendant is not guilty. Now, on the other hand, we have to define an alternative hypothesis. And our alternative hypothesis is denoted as H sub 1, so H1, or in some texts, and the way you'll see me write it a lot, is H sub A for alternative, okay? That's the way I learned it. Try as I may to use H1, I often bounce back and forth between HA and H1. It absolutely cannot contain equality. So the only signs that you'll use for this is less than, greater than, or simply not equal to. Okay, those are your only choices. The alternative hypothesis shows something is going on. It shows that there's a change or a difference or some sort of effect going on. Now, often, even though our null hypothesis is the claim that we're working with, often the alternative is kind of what we're hoping to show, right? Think about the prosecution, right? They're hoping to show that he's guilty, right? So don't get bogged down by what you're wanting to show, okay? You're going to follow on these ideas of which signs go where. Now, while we reject or fail to reject our null, that means that we have evidence to support or not support our alternative, okay? So if we reject are null, then we have evidence to support the alternative might be true. If we don't reject our null, then we do not have evidence to suggest that the alternative is true. Okay, now we're going to do examples and put all of this together, but keep these in mind and be able to go back and reference this as you're putting these pieces together. So in our courthouse example, we had our null hypothesis, remember, was not guilty or innocent, right? What is kind of the opposite of that? Well, our alternative is going to be then that he is guilty. Okay, and you can think about this. If he's not guilty, if we reject the idea, we have overwhelming evidence to suggest, hey, this dude, this is not true. He's not guilty. Okay, he's not innocent. Then we have evidence to say, hey, this one must be true instead. Okay, so rejecting the null means that we throw this one out in favor of this one. And you can kind of use that approach as you go. Now, if you need to think about it in another way, remember that the null hypothesis is that assumption that we're considering, okay? It's what we say, hey, do we think this is true or not? It does not mean that we hope it's true, okay? We're seeing, hey, do we think this is still true or not? Oftentimes, we're doing this because we hope that the null hypothesis is true or is not true. We hope that it is wrong, okay? We are hoping to overturn that null hypothesis. Maybe we've made a change and we want to make something better, okay? The alternative hypothesis is what we think might be going on. So in other words, what is wrong? What do we hope is wrong with that null hypothesis, okay? That can help you get there with your alternative. Now, I want to just pause for a moment and tell you, you guys know what I have done throughout my professional life. When I was learning null and alternative hypothesis, I really struggled, okay? I had a hard time. So I'm going to try to explain this to you guys and try to tell you guys some things that I wish had been told to me. But if you're struggling a little bit to wrap your head around this, you're not alone. So give yourself breaks, get some practice, ask questions, things like that, okay? Now, I mentioned that your alternative can have not equal to, less than, or greater than as your signs, okay? So remember that your null will always have equals, okay? Your alternative will always have not equal, less than, or greater than, okay? Those are the only signs that you can choose, so that might be helpful. So if we use the not equal side, we are going to have what is called a two-tailed test. And in this case, you're just curious if something is different, okay? Is something less than or greater than? We don't care about strictly one way or the other. We just want to know if something has changed, okay? You're just looking for a change. Your null hypothesis is going to be that the parameter equals some value, and your alternative is going to be that your parameter is not equal to some value, okay? Now, I want you to know that your null hypothesis and your alternative hypothesis only differ. They are completely identical except for that sign, okay? So if we're using not equal to right here, then we have a two-tailed test because we're looking at both tails. We're looking to see if it's on the less than side and we're looking to see if it's on the greater than side. Now, on the other hand, we can have a one-tailed test. And a one-tailed test, we only care about one tail, okay? We only care about one side. So maybe we only care about less than. So in less than, this is called a left-tailed test because if you think about the number line or the normal curve, you're looking at the left tail, okay? So you only care if it's over here enough. And in a right-tailed test, you only care about that right tail, okay? In every case, notice that your null hypothesis is the same. In the two-tailed test, you had the null was parameter equals some value. In a left tail, the null is parameter equals some value. And in the right tail, it's equals some value. Okay, so your null hypothesis is identical. It's the alternative that's going to change between the tailedness. Okay, two-tailed we had simply not equal to because we cared about either way. But here on the one-tailed, the left-tailed test we're only caring about less than, and the right-tailed test we're only caring about greater than. So if you're looking for a decrease in something, you're going to know that you're dealing with a left tail. If you're looking for an increase, you're going to look for a right tail. Okay. Your arrow is going to point to the tail if that helps you. Now, I kind of alluded to this. You are looking for keywords here. Okay. Keywords of a two-tailed test might be something like different or change or an effect, something like that. Notice those are not directional. For left-tailed, you might be looking for something like reduce or reduction. You might be looking for decrease, things like that. In right-tailed, you might be looking for increase, growth, maybe anything that has that directional implication. Okay. Now, let's talk about some examples. Let's put all this together. We want to write our null hypothesis and we want to write our alternative hypothesis. I would encourage you to follow along for the first one here, and then I would maybe pause for number 2 and 3 and see if you can work them out yourself. Okay. So number 1, a recent newspaper article claimed that the median home price in the 29680 zip code was $204,000. A realtor believes that the true median is likely higher. Okay. So the first thing that I like to do is always set up, I know I have a null and I know I have an alternative. Okay. I know here I'm dealing with the parameter of the median. Like I said, we won't actually perform these tests, but we can write our hypotheses for it all we want. So I'm just going to use a capital M. Okay. Now, my null hypothesis, remember, has to be equals. Okay. So let's just leave that sign there and let's write our null hypothesis. The newspaper article claimed that the median home price was $204,000. So if nothing is going on, if nothing has changed, that median is still equal to $204,000. Okay. Now, the way that I like to do this is one of the things that I wish had been told to me, is as I write my alternative, remember, everything about the null and alternative is identical except the sign. So what I like to do is come down here and drop the number so that everything is identical. Now I only need to decide my sign. So a realtor believes that the true median is likely higher. That is directional. Okay, that's one of those keywords. She thinks that median is actually more than 204K. So we're going to have that right-tailed test. Okay. Because we are caring about the upper end. Okay, we're caring about higher on the number line. Okay, go ahead and pause if you'd like. I'll walk through this one. The average GPA for graduating South Carolina high school students is 2.81. As a member of the Greenville County School Board, you want to know if your student's GPA differs from the statewide average. So again, I'll set up my null and alternative framework. I'm dealing with the average. Okay, so I'm dealing with the mean. So I'm going to go ahead and write mu here. And remember that my null is always going to be equal to something. So if nothing's going on, what does that mean equal to? Well, it's the same as the rest of everybody else. It's equal to 2.81. Now to write my alternative, remember the only thing that varies is the sign. So I'm going to go ahead and write 2.81 down here, and that'll make my life easier. Now I just have to decide the sign. Now, don't put yourself in these shoes and say, what do you want to see? Read the problem and let the problem do the work for you. You want to know if your student's GPA differs from the statewide average. Differs is simply not equal to, because it's not saying that you're checking, you hope that they're higher, right? But you still need to know if they're lower. You're just curious if it's actually 2.81 or if it's different than that. So you're going to use not equal to. Okay. Let's do the same thing in number 3. The standard deviation width for a certain type of washer is 0.35 millimeters. The quality control manager for a manufacturing plant is worried that the variability might be higher. Okay. So we have our null and our alternative. We're dealing with the standard deviation here. Again, we won't perform these tests. And our null hypothesis has to be equal to something. If nothing's going on, it's still equal to 0.35. So that means 0.35 will be our alternative also. And he's worried that the variability might be higher. So we're going to have greater than. That's it. Okay. So remember, you guys know I can't write and type at the same time. Remember, the null and the alternative differ only by the sign. Everything else has to be identical. Okay. And we don't use any sample information to write our hypotheses. We only write our hypotheses based on what we do before we ever collect the data. So what we're making our assumption on. Now, remember, we're not proving anything with our results, but we can make one of two decisions. We can either reject the null hypothesis or we can fail to reject the null hypothesis. If we reject the null hypothesis, it's because when we looked at our evidence, it was overwhelming that maybe it was not true. Okay, it was overwhelming evidence in favor of that alternative. If we fail to reject the null hypothesis, then we don't have evidence to suggest the alternative is true. Okay, so one way that my students like to remember this is reject is one word and we have is one word. Okay, fail to reject is multiple words. Do not have is multiple words. Okay, and it is always going to be evidence for or not for the alternative. Okay, so our decision is about the null based on whether we can support or not support the alternative. Okay, remember, we're not going to prove anything. You can kind of think about this of if I told you that the average age of Greenville Tech students was 52. Okay, so I say, hey, the average of all Greenville Tech students is 52. And then you selected 100 Greenville Tech students and you found the average age was 23. Okay, that's way off, right? And we're not going to get into the probability here. We're not going to get into any of the specifics here, but that's way, way off. It's so far off that you might be inclined to say, huh, do you think that 52 was right in the first place? That seems a little high. Okay, that's what we're getting at here. The original assumption, and then we're going to look at our evidence and say, well, do we still think that's true based on this data? That's all we're getting at here. Okay, do we have enough evidence to think, yeah, that's probably not true anymore? That's what we're going for. Now, we reject or we fail to reject. What could possibly go wrong? I always show this meme here because when I was a military spouse, my first military move was terrifying. And we walked outside and they were putting a sofa over the balcony to let it out. So yes, I always use this. So what could possibly go wrong? Well, they didn't break my couch, but we could definitely make the wrong decision in hypothesis testing. Remember, those tails go off forever and ever and ever. Okay, so like I mentioned at the beginning of the lecture, we can have a case where that null hypothesis is very much true, but we landed in one of those tails. Okay, or vice versa, we could make the other wrong decision. Okay, this is all complicated by the fact that, remember, with those confidence intervals, I said, well, how do you know that you're one of the green ones when we were in class? How do we know that we're one of the ones that actually contains the true value? And we don't. Okay, so we never know if we're actually correct. If we knew that parameter value, we wouldn't be doing any of this inferential statistics. So we don't actually know our answer here. So there are two possible types of wrong decisions we could have made, and we have to consider that possibility. Okay, the two types of wrong decisions that we can make is that we reject the null hypothesis when we shouldn't have. Okay, so we threw it out, but it was true. And we cannot reject it, so we failed to reject it when we should have rejected. Okay, and this is a type 2 error. Okay, type 1, reject, one word. Multiple words fail to reject, type 2. Okay, Now, a lot of people enjoy using this type of table as they're learning about these errors, okay? So this is what we conclude based on our sample. So this is based on our evidence. So our evidence says this, and this is in reality, okay? It's usually unknown. We don't usually know this, okay? If we did, again, we wouldn't be doing inferential statistics. Now, let's say that our conclusion was that we failed to reject our null hypothesis. So we looked at the data and we said, you know, we just don't have overwhelming evidence to overturn this. So we're not going to overturn it. We're going to fail to reject it. If our null was actually true and we did not throw it out, then we made the correct conclusion, okay? Because we didn't throw it out and it was true. It was a good null hypothesis. We didn't overturn it. Now, if our data did not show sufficient evidence to overturn, but it turns out that that null hypothesis was actually false, then we committed a type 2 error, okay? We made a mistake. We didn't reject, but we should have because it was false. We should have thrown it out, okay? Now, if we reject the null hypothesis based on our data, but the null was true, so we threw it out, but we shouldn't have, okay? We threw out a good null hypothesis, then we made a type 1 error, okay? That's a mistake also. Now, if we rejected and it was false, so we threw it out, but it was false, then we did the right thing, okay? Now, I get it. Your brains might be hurting a little bit, okay? Think about it like this. If your null hypothesis is true, then your alternative must be false. In reality, we should not reject. Because we know that it's true, we shouldn't throw it out. So if we fail to reject, we did the right thing. But if we reject, we screwed up. On the other hand, if our null hypothesis is false, we should reject it because we should throw it out. It's a garbage hypothesis. It's not true. Throw it out. If we don't reject it, so we don't throw it out, we screwed up. We made a type 2 error. If we reject it, then we did the right thing because we should have rejected it. Okay? Now, something that you should keep in mind. At the outset of your entire hypothesis testing procedure, it's possible that you're going to make either mistake, right? You know, you've stated your null hypothesis, you've gone from there, and you know, at the end of this, I could make a type 1 error, or I could make a type 2 error, or I could be right in my decision. However, once you have your data and once you have made a decision, there's only one type of error that you could have made, okay? If you decided to reject the null, it's possible that you made a type 1 error, okay? If you did not reject the null, you failed to reject the null, then you could have possibly committed a type 2 error, okay? Think about that. A type 1 error occurs when you reject, but you should not, okay? So you must reject to commit a type 1 error. If you failed to reject, it's not possible that you committed a type 1 error because it requires that you rejected it. Similar for type 2. In terms of our courthouse example, remember, let's talk about our hypotheses here. Remember that our null hypothesis is that the guy's innocent, and then our alternative hypothesis is that he's guilty, okay? The type 1 error means that we are going to reject the null when we should not, okay? So we're going to say, hey, we want to reject the idea that he's innocent and conclude that he's guilty, okay? So we're going to reject innocence, but he is innocent. Okay, in typical lingo, this is going to be, he's going to be found guilty. But he didn't do it. Okay, type 2 error means we failed to reject, okay? So we're going to fail to reject innocence. But actually, he was guilty. Okay. So here you're going to find not guilty. But he's actually guilty. Okay. Now, right around now, somebody in class usually says, well, which one's worse? And really, type 1 or type 2, neither one is intrinsically worse. It's very much dependent on your situation here. In this case, our system is set up so that we have more type 2 errors than type 1, right? We would rather let a guilty person walk than lock up an innocent person. But then in other types of tests, that's not necessarily true. Okay, that's just the courthouse example. And we'll talk about some examples here in a minute for error types. Okay. 2020 Subaru Foresters have an average gas mileage of 24 miles per gallon. The manufacturer is working on finalizing the 2021 model specs and performs a hypothesis test to determine if the mean gas mileage has changed. Okay, so the first thing we need to do, even if the problem doesn't ask, is set up our null and alternative hypothesis. Okay, so here we're talking about averages, so we're going to be talking about the mean. And if nothing's going on, nothing has changed, the mean is still equal to 24. Okay. Now remember, our alternative also has to be 24. The only thing they can differ in is that sign. So our alternative, he's just curious if it has changed. Okay, so he cares either way, if it's gone up or if it's gone down. We're going to have a two-tailed test with that null sign. Now, number 2. Let's say that the manufacturer concludes the gas mileage is the same, but in reality, it's about 22.5. What type of error was made? Well, what did they conclude? They concluded that it was the same. So that means that they concluded this one, okay? So they did not reject, but they should have. If they did not reject, then they could have made a type 2 error. Remember, that's the only type of error that you can make if you fail to reject, because a type 1 requires that you reject. Now, in number 3, now let's say that they conclude that it is not the same, but in reality, it is 24. So now they're concluding the second one. They're throwing out the idea that it's the same. So here they rejected. Okay. So in that case, it's going to be a type 1 error. When you're asked these, and you will be asked on a test, okay, based on, you're going to make these decisions. And then I'm going to say, well, what type of error could you have made? And really, the important part there is, did you reject or did you fail to reject? If you rejected the null hypothesis, it's possible that you made a type 1 error. If you failed to reject, it's possible that you made a type 2 error. Reject is only one word. So if you reject, type 1 is possible. Okay? Let's think about another example. It's considered acceptable for drugs and a certain class of antidepressant medications to cause night sweats in 5% of patients. Okay? A pharmaceutical company has developed a new antidepressant, and they're currently performing clinical trials to see if fewer patients experience night sweats with their drug. So we already know it works, but now we're curious if it's reducing those night sweats. We want to talk about a type 1 error and a type 2 error. So the first thing we need to do, even though it doesn't ask, is write our null and alternative hypotheses here. We're talking about 5%. We're going to be talking about a proportion. And our null must be equal to something. If it's not any different, if it's not any better, then it's still going to be equal to 0.05. Okay, still 5%. Now, we know that 0.05 has to be in our alternative too, and now we need to decide the sign. They want to see if fewer patients, so we want to see if that proportion has shrunk, so P is less than 0.05. Okay? Now, in a type 1 error, remember type 1 means that we reject but shouldn't. Okay? So in this situation, that would mean that they concluded, if they rejected, that means that they concluded P, that this is no, they're going to throw this out in favor of this. So they're going to conclude in favor of our alternative. So they're going to conclude that it's actually less than 0.05, but really it's not less. Okay, so they're going to come out and say, hey, it's less than 5%, but really in reality it's not. Okay, now a type 2 error means that they're going to fail to reject, but they should have rejected. Okay, and in this case, fail to reject means they're going to leave it alone. They're not going to throw it out. They're going to conclude that it is still 5% because they didn't throw it out. But really, it is less than 5%. Okay. So when you fail to reject, you don't overturn your null. If you reject, you're going to conclude your alternative. Now, in this case, think about which one's worse. Even this isn't clear cut. It kind of depends what standpoint you're from. If they conclude that it's actually less than 5%, but it's not, that means that they're going to advertise, they're going to encourage prescriptions, they're going to do all kinds of stuff and say, hey, ours works so much better. And really it doesn't. That's going to get them in a lot of regulatory trouble, right? That's not a good idea either. Now, on a type 2 error from the drug company standpoint, that's not great either, because they concluded, hey, ours isn't any better, so we're going to miss out on that whole marketing thing. But really, it was less than 5%. So they could have made a lot more money, and they could have, you know, encouraged more prescriptions and things like that, because, hey, they do have a leg up on competitors. Okay. So it really depends when you're talking about which one's better, kind of the scenario at hand. Now, remember, we typically don't know if we made the right decision. Okay. We can talk about the probability that we did make the wrong decision. Okay. These errors, even if you have the most perfect sample, you've minimized your bias, you've done the right analysis, like everything has been done perfectly, you could still make the wrong decision. And that's not on you. Okay. You didn't make a wrong decision. Your probability, you know, by chance, you got screwed over. Okay. And it happens. And that's why we talk about errors. That's why we talk about confidence. Okay. Talk about significance levels, which we'll talk about in the next section. So these errors can and very much do occur by chance. The probability of our type 1 error is, remember, that probability of rejecting the null when you shouldn't. And that is going to be alpha. Now, by now, alpha should sound familiar because we've talked about Z alpha. We've talked about confidence. It's going to be 1 minus alpha. All of that. That's not coincidence. This is the same thing of alpha. Okay. Our level of alpha is called our level of significance. Okay. And that is going to be that probability of a type 1 error. We determine alpha. We set alpha. Okay. It's most commonly 0.05. Okay. Now 0.05 comes back to that whole idea of unusual. Okay. We would say, hey, there's less than a 5% chance of observing this, so it would be unusual for this to be true, so we're going to throw it out. Why would 5% not be great? Well, remember when we learned about 5% probabilities being unusual in Unit 2, right? If a type 1 error is extremely problematic, maybe it's dangerous in a drug trial, you're going to drop that down. 0.01 is a fairly common level too. Okay, we often see 0.01 or 0.10. There are also other common levels. There are other, beyond 120, there are things that you can do to adjust these levels for certain other situations with your data. So if you see a level that's not 0.05, maybe look and see why, especially if it's not 0.01 or 0.10. Look and see if they explain why it wasn't that way. Okay. Now, the probability of a type 2 error is called beta, okay? And that means that we fail to reject, but we should not have, okay? We can calculate this probability We have to make some assumptions, and it is beyond our course, okay? But if you're reading and you see something talking about the power of hypothesis testing, it is very much related to beta. Just for your information, if you're curious, power is 1 minus our beta, okay? And that is going to go beyond our course. So why wouldn't we want to say, well, the probability of an error should be really small. We don't want to make an error. So why don't we make alpha almost 0 and beta almost 0? Well, it turns out that there's a trade-off, okay? And it's not a directly, there's not a number that you can just multiply by to get the other, but there's a trade-off. If you decrease alpha, because remember you're setting alpha, you'll actually increase beta. And I'll spare you the theoretical definition there and the theoretical explanation as to why. But just know that they're kind of like on a seesaw, okay? If you drop one, you have to raise the other. By default, it raises, whether you mean to or not, okay? They go back and forth. They have an inverse relationship. Okay, so you cannot just seek to make both of them as low as possible, because you can't make them both really close to 0, because one getting really close to 0 means the other one kind of blows up. Now, just like we had kind of a cookie cutter explanation or interpretation for our confidence intervals, we can do the same thing for conclusions for hypothesis testing. This is the statement that you want to remember. We either reject or fail to reject the null hypothesis. If we reject, there is sufficient evidence to conclude that the alternative is true, or we fail to reject, and there is not sufficient evidence to conclude the statement from our alternative, okay? So if we reject, there is evidence for your alternative. If we fail to reject, there is not sufficient evidence for our alternative, okay? Notice that this last blank is always the same. You're just going to match is to reject and fail to reject to not, to is not, okay? If we do reject our null hypothesis, we say that our results are what we call statistically significant, okay? Statistically significant just means, hey, it's really unlikely if our null hypothesis was true, okay? So remember that example, I think I used 52 for the average age for Greenville Tech, and you did a calculation and you found the average age was, I think I said 23, okay? It'd be really unusual that you would find a sample with an average of 23 if the average were actually for the whole student body 52, okay? In that case, you may say, nope, I'm going to throw out that initial assumption of 52. I'm going to reject that null. So I do have evidence that it's different or it's less, depending on how we set up our framework, okay? Our results then would be statistically significant because it's very unusual that we would see that if our null were true, okay? Our results are so unusual that we are inclined to think that alternative has to be true, okay? Again, this is where that 0.05 comes from, the unusual, okay? If our probability, which we'll calculate in the next sections, but if the probability of seeing this is less than 0.05, then we're going to reject the null and throw it out, okay? Rejecting means that they are statistically significant. We'll talk in a later section about other types of significance. Okay, so let's talk about an example. A study is conducted to determine whether chewing peppermint gum during an exam increases the average exam score, okay? So in our hypotheses here, we're going to say that our null hypothesis is that it doesn't change anything, okay? I haven't given you any numbers here, so we're not formally writing hypotheses, but let's say our null hypothesis is going to be the idea that no, it didn't do anything to change that exam score, okay? Now our alternative is that it increased, okay? Okay, so our alternative is that it increased. If they reject the null hypothesis, then we say we reject the null. There is evidence to suggest or support that the scores increased. Okay, because there is evidence for our alternative. If they do not reject, we say we fail to reject. And if we fail to reject, we say there is not evidence, not sufficient evidence to suggest, and it's the same thing. Okay, so that tail end of the sentence is the same. Suggest that scores increase, suggest that scores increase. You're either supporting that or you're not supporting it. Okay. So again, the blanks that you're going to fill in are reject or fail to reject, is or is not. Okay. That last blank is always what your alternative hypothesis says. Okay, if your brain hurts, that's okay. I want you to make sure that you use all of your resources and make sure that you are getting with this. Practice is going to help. Remember, there are lots of short videos at the end of the lecture materials in Blackboard. There are other instructors online section videos. There's all kinds of resources in your text and everywhere else for our course, okay? Lots of things at your fingertips. Remember that the Math Center is available. Remember, I'm available by email. You do have homework for this section. Make sure you reference your course schedule or any emails from me, and practice, practice, practice. Okay, I hope to see you guys soon. Thanks for tuning in.